What are you saying? Be very precise and clear now.
Right. What I'm saying is.
Don't use indefinite articles. Don't say it, she, he. Say Alan, Paul,
Yeah.
John. Okay.
Well, what I'm saying is based on the graph, so that's what we find out the infinite, right? If the graph is above, just like what we doing before, just like Simon graph. So if the graph is above to the curve, it will be infinite, right? And if below is
Say that
finite,
again. If the graph is above, yes.
infinite, right?
What? If the use a complete sentence. If the graph is above,
Right. It's infinite, right?
what is the verb here? If the graph is above,
Infinite, right?
you need to say Alan is infinite.
Oh.
Or something like that. Okay.
Okay.
If the graph is above,
Ln is infinite. That's what you used to do.
if the graph is above, and what?
Infinite, right?
Why is it infinite?
Because that's what you're talking about, right? So the graph is based on the area.
No, you missed many steps there. I'll do it again.
Okay.
Supposing I have the situation here.
Right.
Now, I have that situation because my hunch is what, Mr. Harris, about this area here.
It's fine.
Go and think about it, but you are correct. He has a hunch that this is finite, which is why he's shoving it underneath. Hold on.
Yeah.
My turn now. He is going to have to do what, Mr. Bess?
The underrecord.
Huh?
Trying to reckon it's underrecord.
Who's awake?
You want it above because that's larger and it's finite. Anything underneath it can be finite.
So he has a hunch that this is finite. He shoved the rectangles underneath. It remains for him to do what? Mr. Rubino, let's see. He has a hunch that this is finite.
Yes.
Hold up. He has a hunch that this is finite, so he shoves it under this curve, and it remains for him to do what? To conclude that this is finite. It remains for him to do what? Mr. Rubino.
Remain finite.
Mr. Collas, tell us
You gotta integrate.
and show us that the integral is.
Is finite.
Yes.
That is it. Do you see? There were a lot of verbs there. Not finite. Mr. Collas, in definite article, is going to show verb that the integral under the curve is verb finite. If he does that, he has proved to me that the area under it is finite. And if the area under it is finite, then this and this and that, it is finite.
Okay. I got you.
I hope so. And of course, I told you the other case, if he is going to shove the rectangles above, he has a hunch that the series is. So he will have to show what? That the
And rule is infinite.
that is the logos. Involves two things. Now we did it last time with this. We did it last. Take a look at your notes. That's exactly what I did. Is that what I did, Miss Yasmina? I looked at 1 over x squared and I integrated it from where to where? 1 to infinity, and it turned out to be finite or infinite? Huh? Finite. So if I shove rectangles underneath it, they are going to be finite. And the rectangles underneath it are 1 over 2 squared, plus 1 over 3 squared, plus 1 over 4 squared, plus 1 over 5 squared, plus 1 over 6 squared. Do you see it? Mr. Halford.
So if the area under the curve
Yeah.
is finite, would that converge or?
No, you have to describe the situation. If the area under the curve is finite, what can we conclude? Nothing! We have to make sure the rectangles are
Under.
UNDER. If the area under the curve is infinite, we may conclude what? Nothing! However, if the rectangles are above, then we may conclude absolutely. I'm sorry, the logic is quite demanding.